we need to talk about something. And that something is containers. Because we probably all use container. But let's get into the fact, what is a container? First of all, a container is a receptacle. A receptacle for instance, holding goods, or a portable compartment in which freight is placed. It can either be to preserve it or to ship it. So it can either be something like this, a soda can to hold your soda and keep the bubbles inside and make sure that it tastes good over time, or your beer, of course. It can also be the airtight container you use to store your leftover food and to make sure that if you open it and you consume the food, it's still as good as possible. But with that description I gave you, it can also be something like this, and that's more like you think of a container, right? The storage container or the shipping container you put on a ship, a boat, a train, or a truck to transport goods from one place to another. If you look at these containers, they are some sort of security layer. They try to keep the content of the container, or the inside of the content that's inside, to preserve it for a specific reason. So it's a protective layer around the inside, around the goods you want to preserve, to make sure that the outside world doesn't have so much influence on them. Think about it. You don't want to lose the flavor of your soda in your soda can. However, you need to pick your container accordingly. Putting your soda or putting your beer in the airtight container might work, but is not really good for it. Putting your beer or your soda bluntly in a storage container without the can around it doesn't work as well as just putting it in that soda can. So what I mean to say is, it helps secure the content. And with that mindset, we might think the same way as if we were working with containers in software engineering. So, for instance, say I put that same analogy to containers in software. I have a Java program in a container. People thinking about containers in real life, that putting a program in a container by default makes it secure. Unfortunately, that is not true. Of course, it depends on what kind of container you have. That is the first thing that you need to be done. But also, there is a slight difference between the container in the real world and that container containing your program. Because in this case, we do need to make sure that we have contact with the outside world. We have interaction. Your program probably needs to get pinged by a user or get influenced by a user, for instance, with a web browser. Or you need to connect to a database or data source. So it's more or less a container with specific holes in it. So the analogy of putting software in a container makes it secure, or putting your Java program in a container makes it by default secure, is absolutely not true. And that's what we're going to talk about today. But first, my name is Brian Vermeer. I am a Java engineer and currently a developer advocate for a company called Snyk. I live in the Netherlands, and from that space, I'm going to present this to you today. I do a bunch of stuff for the community. So currently, I am leading the Virtual JUG and the Utrecht JUG as part of the leadership team. There we do a bunch of meetings virtually and on site when it's possible again, and help the community create better Java programs and try to learn new things. Next one, the DevSecOn community is a application security community where we focus more or less on creating secure applications, but from a developer perspective. Last but not least, I am a Oracle Groundbreaker Ambassador for a couple of years now. But that's not why you're here, because currently we are talking about containers. And I'm going into Docker containers, because Docker containers are heavily used. If you look at Docker containers, there are currently over 1 billion weekly downloads of Docker images that you pull from Docker Hub. So although most of these things can also be applied to other types of containers, and luckily we have more than Docker, Docker is still the most widely used form of containerizing your application. Therefore, I better could say this is a best practice for Docker images. specifically, or more specifically, for Java engineers. And most of these things can be also applied to other ecosystems, but I will use, as we are on a Java conference, Java programs as the example and how to do it specifically for Java. So let's get into the first one. The first one is about your base image. And the title of it is Prefer a Minimal Base Image. Because a year ago, well, a bit more over a year ago, we are already in 2021. I did a research on Docker containers specifically, and I pulled the 10 most commonly used Docker containers from Docker Hub, and I scanned them for known vulnerabilities in that container. And these 10 most frequently used free containers, it looked something like this. And what you can see is that all 10 of these containers do have vulnerabilities. It can be up to 500 or only 31, but these are just the numbers. I'm not saying something about severity or how you can influence them, but all of these have problems. All of these things have issues. And that comes because what we did, we pulled the latest. Without any given tag, any specific tag, we pulled the latest version of each of these containers at that point in time. And what we saw when we scanned them is that they have vulnerabilities. And most of these vulnerabilities, take for instance the Node.js one, that one, most of these vulnerabilities were could be traced back to the base image that Node image was based on. So that Node image was based on a somewhat older Debian Jessie image. And that Debian Jessie image had a bunch of operating system layer vulnerabilities inside them. So that means if you build your container on top of a container, or you build your image on top of an image that you pulled from Docker Hub, you get all these vulnerabilities for free. Therefore, you should be aware of what do we pull in to create a container that you want to have your application in. Because if you look at, for instance, the different operating systems, there are a lot of differences. If I take, for instance, a Fedora or an Alpine-based image, or a Debian one. So that makes you think, like, do you actually need a full-blown operating system to run your Spring Boot application or your Quarkus application? Probably not. So not just taking the latest image like you see at the first bar with Debian, but taking, for instance, the Debian Stretch Slim, already reduced the amount of vulnerabilities you have to worry about in your application. Again, this is of course a point in time where we did this scanning. The numbers can be quite different now, although it seems like Fedora and Alpine, because these images are quite smaller, they have less known vulnerabilities for binaries that ship with these operating systems. If we look closer at a bunch of Java images, for instance, from our friends of Adopt OpenJDK, and I take the Adopt OpenJDK 11 images, you see there is, again, differences between the Debian one and the Alpine one. By default, OpenJDK or Adopt OpenJDK ships its latest image, so without any further tags, it's an Ubuntu-based image, and that's already quite significantly lower than the Debian one. So picking your image carefully, because that is the foundation of your container that you're building, or of the image that you want to build, is very, very important. Just like building a structural building, house or something, the foundation, you should take care of that. And that is because, for instance, Linux operating system vulnerabilities steadily increased over the years. And I don't say there weren't any in 2008, but maybe they got found better. At least they are known. And when a vulnerability is known, it can be exploited. Maybe, maybe not. You should at least be aware. Let's go to the second one. And the second one is the least privilege principle. Make sure if you create a Docker container that, or you want to run a program, that the user that you're using doesn't have, for instance, root credentials, but credentials that are fit for purpose. Nothing more, nothing less that it needs to do. So if I'm looking at an image, by default, we know that an image, if I don't specify a user, it will be run as root. So therefore, in this image, I made sure, or this Docker file, I made sure that I created a user, a new user, and I made sure that it's the owner of the application I'm working in, or the owner of the folder I'm working in. And I'm calling it. So the most important lines in this case are this one. The first marked line creates a group and a new user, a system user without shell access for that group. Then we give it ownership in that second marked line to the working folder. And the third marked line is just as important because at that point I'm calling that user. So every command I call after that is called with that specific user. If I forget that line, I created the user, I still made it the owner of the folder, but I'm running the next command as root. So make sure that you call that one. In this case, you know that the user that you're using is specifically built for that application. Also, for some cases, and I'm taking a Node.js container over here, it already supplies that user. And again, even though it already supplies the Node user for my Node 10 Alpine image over here, you have to be aware that you still need to make sure that that user is called before you call the command. So not only create the user, but don't forget to call that user that has the less privileged user over the root. Next one. During development, but also after that, we need to make sure that we can find, fix, and monitor. So finding and fixing during development, but also monitoring your open source dependencies, also in the in the operating system layer. Because I already showed you something, but build packs are part of the Docker ecosystem, and picking your build pack or whatever image you're using is very important to what the foundation is. And I already told you that. But as you know, vulnerabilities will be found over time. So we asked people the question in our State of Open Source Security last year, like, when do you scan your Docker images for operating system vulnerabilities? Fortunately, we can say that half of us did, or somewhat did, but half of the respondents did not. So we see that a bunch of folks don't know what's actually part of their Docker image, especially when it's in production. Things we can do is, for instance, we can pull a Docker container. And with tooling like the tooling my company provides, Snyk provides, we can do container scanning. And I will give you an example of this. So I pull a Docker image like the OpenJDK 11 image over here, and I can scan it with my Snyk container test. And it's part of the Snyk CLI that you can use and you can download and use for free. And by doing a Snyk container test and then the image and its specific tags, I can test that image and see if there are vulnerabilities. And I will show that to you. Like, if we go over here, and I already prepared something, and in this case, I'm scanning a different image. I'm doing a Snyk container test on Maven 3 OpenJDK 8. And by scanning this, it will analyze my container, that specific container. I downloaded it. I don't even have to download it, but you can. Probably you already did. And it analyzes what kind of dependencies and what kind of binaries are already known for that or in that container. And it will give you an example. It will query our database at Snyk, and it will give you an example like this. And I will wait for 2 more seconds because I already prepared this one. 1, 2, let's check out this one. So because this is the same thing I already did just before this recording. And what you see is that it gives you a bunch of vulnerabilities. And you see that all these vulnerabilities are going back to Debian. Debian 10, Debian 10, Debian 10. So because this Maven image for OpenJDK 8 is built on Debian 10, you will bring in a bunch of this stuff. And do you need them? Do you actually need all these binaries? Think about it. why not test your container or test your base image before you actually use this? But also while you are using this. Getting back to my slide deck, you will see that in the second line, or in the second command, I also did a -- file at the end. So if I create a container myself and I supply the Docker file with it, we can give you more information, not only what is the problem of your specific Docker image that you're building, but also can we remediate the base image? For instance, if we know that you can use a base image with another tag that gives you less vulnerabilities, we will supply that information to you. And we supply that we will supply that the information, like what kind of vulnerabilities are there. So you have a clear insight, is this important to me or not? Because that is up to you. It's your context. It is your application. The last command over here, you can monitor it. That's perfectly fine, or that is even better if you want to move a container you built to production. If I monitor it, it will be sent to the Snyk UI or to your account, and we can monitor it over time. So over time, we can see if your image or your Docker image, your Docker container, has vulnerabilities or there are new vulnerabilities found. So we can ping you actively, and that is more dev first than just saying you have to do it once in a while. So actively doing when you are in production is a big plus. And it will look something like this. So you see a Docker image and you see if there are a bunch of problems in that. All right, getting on to that. Did you know that 44% of the Docker images, the vulnerabilities, can be fixed by a newer base image? So just by switching out the base image to a version that has another base image of itself, so the Debian one versus the Alpine one, for OpenJDK 11, for instance, can already fix a bunch of vulnerabilities and makes you less vulnerable to certain things. So we asked people, like, how do you find out about vulnerabilities in your deployed containers? And again, a lot of people don't, because most of the time we think of it's fixed, or we created it, it's done, we ship it to production. However, we still need to take care of that, because when it's in production, it's customer facing. And if a problem can be exploited, then at that point we're actually vulnerable, not in development. So we should do everything, like fixing it or scanning it on forehand, but also when you are in production. Did you also know that 20% of the Docker image vulnerabilities can be fixed by just rebuilding them? Because people use a lot of the latest or a specific tag, but not actually the hash. For instance, and that this is a very common way of doing, but not so much a good way, is like this. Say I do something like from Ubuntu latest, and then I am inserting, I'm doing an apt-get install on Python. The latest image of Ubuntu today is different from the latest image a week from now and a week ago. So that means that the amount of vulnerabilities that are found and that are probably already fixed that can be a tremendous difference. The same holds for things like your key binaries that you install. So keep monitoring this and make sure that over time, even though your application may not have changed, rebuild your container. If you use a specific version of an image with a hash around it, like that specific base image and nothing else, you still need to see if there is a newer version with less issues, or maybe newer issues came in and you want to fix them. But if you do it like this, just rebuilding the image without rebuilding your Java jar or WAR file could be beneficial for your security reasons. And if you do that, make sure that you do or you give the Docker build -- no cache. Because we do want to bypass the cache if you do that in your build farm or something like that. So you are sure that you actually download, in this case, the latest version of Ubuntu. But then you would say, hey, yes, containers, whatever, all these binaries that are there, what can possibly go wrong? Well, let me show you something. And this is something because it's chained, it's interesting. If something goes wrong, it's not just one thing that goes wrong. It's always a chain of things that went wrong. Somebody found an insight, went through it, and because it found this insight, it found out that over here there is another binary and we can exploit that. It's not just only one thing, it's a domino effect. So let's look at this problem. It's an improper input validation on image magic. And image magic is a binary that is served to you on basically all Linux distributions, on Debian, on Ubuntu. And for a specific version of ImageMagick, there was a problem in it, improper input validation, and also known as image tragic, which, well, is kind of fun, in my opinion. However, without explaining this, let me just show you that what can go wrong with the vulnerabilities in my container. So, say I am having a Docker container. Docker container already works over here, and let me get to that browser. This is a Docker container that has a small web application that can resize a picture for me to a Twitter format. And the Twitter format is 282 by 150. So if I choose a file, and let me choose a file from my pictures, and let me do something stupid like, well, let me just do my own picture from pre-corona time. And I resize it, and you see it resizes it back to a nice Twitter size image. Okay, that's all fun, but it uses ImageMagick, one of the binaries in my operating system, to do that. Unfortunately, it has a problem. If we connect to the Docker image, you see that nothing special is there. It's the Docker file, the Docker Compose file in this case as well. So there, and my complete application is, in this case, it's a Node.js app because that was easy to build at this point. However, I'm having an exploit, and let me look at this exploit here. It's a JPEG that we trigger that improper input validation in. And as you can see here, this is the context of that JPEG. And in that JPEG, what we try to do, we try to fill that view box here with the stuff, an URL, although we break out of it and we say touch RCE1. So basically what we're trying to do is we're trying to execute the code touch RCE1 by just loading this image. And let me see if this works. So choose the file, go back to my Snyk demos, and I see in my exploits over here that I have RCE1. Let's open this file and let's resize it. And what you see is that we actually do not have an output because, well, it broke out of that HTTP oops.jpg or what's there. And probably we now have a file called RCE1. So let me do an ls-l in my Docker container. And you see that over here we have a file. So that means I can do arbitrary code execution. That is fun. But if I can do arbitrary code execution, I can not only create files, I can delete files. But I can also create scripts. And I can create scripts that if my Docker container is connected to the internet, that I can download other binaries that may be included or influencing the container. It is an awful thing. Something you do not want. Let's continue. Up to the next one. Use a linter. Just like you want to check your code with linters or code analyzing tools to see if there are problems in there, you probably do that in your IDE. You can also do that with your Docker file. And a good one is using hadolint or hadolint. And it will give you tips and tricks, or it will give you some instructions like how can you improve your Docker file to make sure that it's clean, conform any standards, and that bugs will be disclosed as easy as possible. Here another example: things like use copy instead of alt for files and folders. All right, up to the next. Application dependency impacts container security as well, because if you think about it, and this is the application you put in the Docker container, the amount of code that you probably wrote is something like this. And you do heavily editing on that code with code reviews and pair programming and that kind of stuff. But what about the yellow ball behind it? That's all frameworks and dependencies. Do you know what's in there? How much do you update these dependencies? Because if you know that new dependencies or new vulnerabilities are disclosed every single time in different ecosystem, and if you can see Maven Central as a benchmark here is growing as well. And that's not because of Maven Central, but because people find new vulnerabilities in existing packages. And if you look at these problems more closely, you will see that it's not so much the direct dependencies. In the middle, there's the column for Maven Central. It is the layers below, because dependency you pull in is okay, but dependencies below that and below the other one and below the other one, probably not. So what you can do is you need to scan your application to make sure that these dependencies are not there as well. Next one, multi-stage builds. For instance, if we build an image, and you saw that I built an image earlier, it's not always that we always need that stuff, but probably only in build time, not so much in your production image. And there is a difference between the build image and the production image. If you build an image, you use this compile stuff, you use the stuff to compile the program, you use this stuff to set up, but that doesn't necessarily mean you need that in your production image. So there is a difference between the two. For instance, if I build a naive image for a Spring Boot application like this, using a Maven 3 OpenJDK 8 image, it perfectly works. But first of all, it's over 600 megabytes big. Second, it includes the complete JDK, it includes Maven, and it includes all my source files. So if somebody, for instance, can have shell access to that, he or she can alter my code and recompile it and run it while the container is still alive. Not something you want to have. So you can change this and still use that image to build it, but use a separate image to put into production. And then we can use multi-stage builds in Docker, like this. So the first image is still using my Maven 3 OpenJDK 8 image and builds the stuff. But then on the second part, you see that I'm using a OpenJDK JRE, a Java runtime environment, because we don't need the JDK in production. Based on Alpine, because that's small and there are a lot less binaries in it, so they cannot harm me. I simply copy only the jar, and I make sure that I call it java -jar. To make it absolutely perfect, you should, of course, create a user for this specifically. So as you can see, this one is only 132 megabytes big. So it's easier to ship and probably also faster to deploy. Moreover, it is safer, and that's the important part we do over here. Even if we need to do other stuff, like in this one, this is an example, again, from Node.js, and that somebody puts a authentication token in. You don't want that authentication token in the cache of your image that you put into production. So instead of putting it to production, make sure that you do that multi-stage build again. So these things that are in cache somewhere in that system are gone. So doing it like this, make sure that you get rid of all these things like credentials you only need for build time. Just remember that attackers are targeting open source, and that's both your application, but also your container. Your container is just as much a liability as your application itself. It's just more stuff you include to make sure that your program works and is shippable. But that also means we need to take care of that. We need to at least be aware of what is the problem or what are potential problems with your application. So to sum up the last few things. First of all, choose the right based image. Do some research. Don't just pick one, but maybe pick a smaller one or pick one that's based on a minimal operating system. Rebuild the image often. So if you use the latest one, rebuild it often so newer things will be fixed. And that also helps for your application. So scan your Docker images during development. I told you about that. Use multi-stage Docker build so you only include what you need. Not the complete JDK and Maven, only the Java runtime environment and your executable jar. Use a security linter for Docker files like I show you with hadolint, and don't ever run your containers as root. My name is Brian Vermeer. Containers are cool, but be responsible. Thank you for watching. Enjoy the show.